All right, so you all have standard form up there, right? Yes? Okay, so how do you find your vertex in standard form? What is the B right now? It's 2, so you're going to make it over 2 times, what's the A up there? Okay, so what do I actually have in my denominator? So what is negative 2 over negative 2? Positive 1. How are you now going to find the Y value? You're going to plug it in. I'm going to take that 1 and I'm going to put it in. Uh-oh. That's not good. I'm going to put it in. It seems to be working, right? Okay. Okay, so I'm going to put it in for X. Now, folks, remember that negative symbol has to go outside of the parentheses when I plug it in. So what do you get? Uh-oh. You said 1, you said 2, so what do I actually get? How about the rest of you? 2? Get 2? So there's my vertex. Okay, the next thing they asked me for is the axis of symmetry. What cuts this thing right down the middle? X equals 1. Okay, last thing I need is the y-intercept. Every y-intercept has an x of 0. So if I put a 0 in up here for the x's, what is my x-intercept? This will end up being 1. And remember, the point would be 0, 1, because didn't I plug in 0 for x anyways? Okay, good. I think I'm going to forego number 3. If that's okay with you guys. Good? Okay, so now I'm down to this chart that we've seen for, I think, 5 days now. Yes? We're only going to fill in 2 boxes or 2 rows, okay? Somebody tell me what a linear equation looks like. What does the M stand for? Slope. And remember I told you, when you guys go to that state test, a lot of times they don't call it slope. What do they call it? Rate of change. Okay, and what's the B? The y-intercept. And folks, remember when you graph these things, you always start at the y-intercept. I don't know if you remember that back from before Christmas. You always start at the y-intercept. When do we use linear equations? What do those show? Yes, it's going to make a line, but how do I know to use them? Uh-oh, you better get out your notes from the other day and look at it. Get out your notes and look. What do linear equations show? Constant change. Because I explained to you that when you graph this thing, the slope never changes, right? If it's 1/4, you're supposed to go where? Up 1/4, and up 1/4, and up 1/4, and up 1/4 until the end of all time, correct? Which means it doesn't change, and that's how we get our line. Okay, what does an exponential equation look like? Come on, folks. AB to the x. What's the A stand for? What's the B stand for? And where do we always start with our percent of change, folks? Always start at 100. And then we go up or down from there. Good? So if I'm at 100 and I say I want a 10% decrease, where is that? 90. If I'm at 100 and I say I want a 25% increase, where is that? 125. Okay. And when do we use exponential equations? Shows percent of change. And I've reiterated this to you a lot. Remember when we double things or triple things, that is percent of change. Because if I double 100%, where is it now at? 200%, right? What about taking half of something? What percent would that leave me at? 50%. Great. Okay, and then this is what we've been doing last week. What's a quadratic equation in standard form look like? Good. And the most important point of quadratic equations is the vertex. How do we find the vertex in this form? And remember, folks, this only finds you the x coordinate. To find the y coordinate, then you'll plug in that x value to get the y value. And then the easier of the two was vertex form. That just had a few more variables in it, if you remember. Does anybody remember vertex form? No. Well, you guys are going to need to know this for your test on Friday. Ah, we got it. You guys better be asked. Maybe we should be filling in this entire chart. Okay, and then what's the vertex in this form? Correct. And when do I use quadratic equations? What's the point of doing a quadratic equation? It shows a min and max. So if I want to know how high something goes or how low something goes, I'm going to be using a quadratic equation. All good in the neighborhood? Yeah? Okay, so I should be down at the bottom now. And again, this is nothing new. This is just more practice. Eventually, hopefully by now, you guys should be able to do this independently. Except for maybe Greg, who's missed some of this. How's it going so far? Okay. All right, so take a look. It says consider the function. A, determine if it has a max or a min. State the max or min value, and then determine the domain and range. Do you need to graph this in order to do that? You don't. Could you graph it? Yeah. Good. Yep. A min, because folks, this will be a smiley face, right? The way we know it's a smiley face is if it starts with a positive, it's going to be face up like this, like that. If it starts with a negative, it'll be face down. If it's face up, that means it's going to have a minimum value. Okay, so William is correct. It does have a min. Now, part B, it says, what's the minimum value? Where does the minimum occur? What is that point called? The vertex. So if I'm going to find the minimum, I got to find the vertex. Is that in standard form or vertex form? So I'm going to go ahead and write that underneath here. Do you guys think it helps to write it underneath there? Yeah? Okay, so what's the B right now? So what is the B right now? So you're going to make it negative 18 over 2 times what's the A? That 3? What is in the denominator, folks? 6. So this is really negative 18 over 6, which is what? Negative 3. Whoops, I don't want to close that because that's only the X value. How am I going to find the Y value? Plug it in. Make sure we're getting this in parentheses when we do that. And what is your minimum value? Come on, some of you guys need to pick up those calculators and get going. Negative 48. I did not get that. Doesn't mean I couldn't have made a mistake, James. You get negative. Maybe I did make a mistake. I never claimed to be perfect. I'm now getting negative 48. So, which one is the minimum value? Negative 48. Remember, folks, if I'm talking max and mins, that's high and low, right? Up and down is the Y value, which is why they're asking for the Y value here. Finally, the domain and range. Well, it's a parabola, right? So what's always the domain for a parabola? All real numbers. And then the range. We said this is a minimum. So does that mean the y's have to be bigger or smaller than that? If it's a minimum, everything's going to be greater than or equal to that. And what is the y value at the minimum point? Negative 48. Good, I need to fix that on my sheet. Okay, how we doing? A-okay? All right, moving on. Is that standard form or vertex form? Okay, so I'm going to go ahead and write that in. Part A asks me to find the max or the min. Is this going to be a max or a min? It's going to be a max. Tell me why. Because it starts with that negative, which means it's going to look like that. Say that? It's all sad because you can remember it that way. That's perfect. Part B, I actually need to find the max value, which means the max occurs at the vertex. Good. So what is the B right now? Well, right now it's negative 16, but you're going to turn it into positive 16. So what's in the denominator there, William? Good. What is negative 16 divided by negative 4? Negative 4? You guys remember with these earphones on, I can't hear very well. What are you going to do with that negative 4? Plug it in for x. Greg, how you doing? Still okay or not really? 50? That's what I got as well. So which one of those numbers is the maximum value? 50. Part C, give me the domain. And the range. If this thing is a max, the y's have to be less than or equal to 50. You got it. Okay, folks, I want you guys to try number 3 on your own. The whole thing. A, B, and C. Go ahead and try that on your own. All right, folks, so I hope that you wrote standard form underneath here. Is this thing going to be a max or a min? It's going to be a min. What is the vertex? What did you get for your vertex? That's what you should have gotten. That is correct. How did you all do there? I tell you, if you get the x wrong, you got no shot at getting the y correct. So what is the min value then? Negative 56 is the min value. So part C, I need the domain. And then for the range, if that's a min, the y's will have to be greater than or equal to. Now make sure that your arrow points the right way because you guys get greater than and less than mixed up a lot. Mm-hmm. Yes. It would look like this when you plug in the negative 5, right? Correct. The only thing that changes is that x becomes a negative 5. Yes, yes. Good. Okay, so any questions on that? No. So then on Friday, we started to do these word problems, right? On these goofy situations that I was giving you. I think last week we had me hitting a golf ball. What else were we doing? A javelin throw and a bow and arrow. Okay, so all of those things make the same shape in the air. What shape do all of those things make? A parabola, an arch. It will look like this. If something goes up into the air, it has to come back down, and this is a parabola shape. This is a U shape that we've been talking about. These are quadratic equations. Okay, quadratic equations, which is what we've been talking about for about a week now. Okay, so the cheerleaders at North High School launch t-shirts into the crowd every time the truckers score a touchdown. Does the situation make sense to you? You all seen those t-shirt launchers, right? They launch the t-shirt up into the air and it comes back down. It's a parabola, isn't it? The height of the t-shirts can be modeled by the function. So I'm going to go ahead and put a box around this. That's the good stuff. That's what I need to know. Now, do you guys see how it starts with h of x? What is h of x the same as? Y or f of x? That's all the same, isn't it? Okay. And x is representing what, ladies and gentlemen? Seconds. Okay, here we go. What is the maximum height the t-shirts will reach? Now, first of all, where does a maximum occur? At the vertex. So I need to plug this into Desmos, and I need to figure out how high will this thing go. Are you ready? I'm going to need somebody to read this off to me here. All right, y equals... Ooh, you guys are like little robots. Y, hold on a second. Y, which one is equals? That one? Negative 16x squared, okay. Plus 48x plus 6. Okay, so I'm going to need to zoom out a little bit. Or a lot of bit. And there we go. How's everybody doing? Okay, somebody read me back the question again. What did it ask me? The maximum height. That occurs right here, doesn't it? So how high will those t-shirts go? 42 feet. And if I were to ask you, how long does it take the t-shirt to reach the max height? 1.5 seconds, but I didn't ask you that, did I? Actually, I might have in the next question. Let me look here. Oh, I did. So this one was what, 42 feet? Okay, how long before the t-shirts reached their max height? That was up at the very top. 1.5 what? Seconds. And finally, at what height was a t-shirt launched? Now, if I am looking at this graph, how do I tell how high the t-shirts were when they took off from that cannon? It's the y-intercept, and this point right here is the y-intercept. 6 feet. Now, do you guys see how they put another point right here for you? Not relevant. Don't use that point. Okay, that's the x-intercept. That doesn't mean anything for me here. So 6 feet is my answer here. Now, the one question that I asked you a lot last week that I failed, and I'm not really sure why I didn't put a part D here. I could ask you, after how long will it hit the ground? That happens right there. How many seconds would it take to hit the ground? 3.12. What does this 0 represent? It's hitting the ground. That means it's at 0 feet, right? That means nobody caught the t-shirt the cheerleaders shot out of the cannon, and now it's laying on the ground. Okay. Any questions on this? Greg, how you doing? Okay? All right. Moving on. The marching band is selling poinsettias to buy new uniforms. Well, our marching band sells fruit and poinsettias every year, don't they? Okay. Last year, the band charged $5 each, and they sold 150. They want to increase the price this year, and they expect to lose 10 sales for every dollar increase. The sales revenue are in dollars generated by the sales can be modeled by the equation. Right there is the good stuff. Where P is the number of $1 increases in price. Now, ladies and gentlemen, I want you to look at this equation because I want you to understand how this makes sense. Now, we're not talking about throwing poinsettias up into the air and bringing them down, are we? No, this is not one of those types of questions. But, again, take a look at this equation, please. Okay. They start at $5, don't they? They're going to increase by $1 or $2 or $3, right? Whatever they increase by goes right where that P is. So if I increase by $3, now the price is what? 8. 5 plus 3, which is 8. Does that make sense to you? Now this next one, they sold 150 of them, correct? But every time I go up by $1, that means 10 less people are going to buy them. So if I increase by $2, that becomes a 20, correct? Meaning I will sell 20 less poinsettias. So does this equation make sense to you? Okay. Part A, write the function in standard form. That is not standard form, is it? Standard form means no parentheses. How do I get rid of the parentheses here? What do I need to do? distribute. I'm going to cut it in half and distribute. It's been a while since we've done that, isn't it? So what will that look like if I do that, folks? Nope, plus. Does anybody have any questions where that comes from? It's been a while, hasn't it, since we've done that? Okay, so let's multiply this out. What do I get here? Thank you. What do I get here? What do I get here? And what do I get here? Good. You guys see? I'll see how that's p squared. What gets to go together? The negative 50p and the 150p, right? Folks, what do I get when we put those together? Nope. Negative 50 plus 150. 100p and then the minus 10p squared. And folks, this is r equals. If we are looking at this, what is the r representing? Nope. R is for revenue. Revenue is money, isn't it? And in this case, where that r is, wouldn't that be where the y normally is? Okay, what is the p representing? X, and what is the p representing up here? What's p stand for? Dollar increases in price. Good? Okay, it says find the maximum value. So what are you going to do with this? Type it into Desmos and find the vertex. So I am going to need somebody to read that off to me here. All right, what do we got? Well, I'm going to do y equals, okay? Y equals 750 plus 100, you said? And you said x? I don't know if it'll do it or not. You'll have to see. Did it still make a parabola when you typed it in? Oh, okay, we're good then. Okay. And then what's the last part? Minus 10p squared? And I'm going to use x's here since I already got x's. Why did it do that? Minus 10x squared. Okay, looks like I'm going to have to zoom out some more. And some more. Oh, that's a big parabola. I think I'm just going to move it. Holy smokes. Right up there? Yeah, that's all right. Okay. So, maximum value. 1,000. 1,000 what? Dollars, correct. So this will be $1,000. So that means the maximum amount of money they can make is what? $1,000. How much revenue will be brought in by increasing the price by $3? Folks, if I am increasing the price by $3, what variable is this? Price is P, isn't it? So what is the P going to be? 3. What do you think I should do with that 3? Plug it in. So I have 750 plus 100 times 3 minus 10 times 3 squared. How much money will they bring in if they raise the price by $3? $960, she says. How is that, guys? Question though, if I raise the price by $3, how much am I now selling them for? Okay, think about what we're talking about here. What did the price start at? No. What did the price start at? $5. And I did a $3 increase. So if they sell them for $8, they're going to bring in $960. Good? Okay. How much should they sell the poinsettias for to earn the most money? Five is what? The x. Folks, look at this right here. The 5 is the x, right? The x is the same as what variable here? P, right? So that means I'm going to increase it by $5, which means now how much will my poinsettias cost? $10. So for them to make the most amount of money possible, they should raise the price to $10. Now, I know you guys always ask us math teachers, when are we ever going to use this stuff, right? This is something you actually could use it for. You want to make the most money, right? So figure out where the max is, which is a vertex. $10. Questions for me? No? Got one more left? A football is kicked up from the ground with an initial upward velocity of 90 feet per second. The equation gives the height h of the ball after t seconds. At what height was the ball kicked? Now, you shouldn't even need an equation for this. By reading the problem, at what height was the ball kicked from? 0, the ground, right? So when I type this in, it better give me 0, 0 as my y-intercept, right? Let's see if that happens. Y equals, what was it? Holy smokes, I better zoom out. Or zoom in. Oh man. Where is it? There it is. Okay, so does it give me 0, 0? Maybe it does. There it is. We're good, right? Okay, so 0 feet. What is the height of the ball after 1 second? Ladies and gentlemen, what variable up there is seconds? T. So the T is going to be 1. What do you think you should do with that 1? Plug it in. So after 1 second, how high will it be? 75? 74 feet. There we go. It's okay. How high will the ball travel? That's the max, isn't it? Which if I look at this, the max is right here. 126.56. Okay. And what is that? How long will the ball be in the air? Now, if it's in the air, that's from top or from beginning to end, correct? That one right there? 5.625 seconds. Questions for me? You sure? Almost all the way sure, so that means tonight you'll do your homework, right? Okay. Homework for tonight. Okay, so I stress to you again, make sure you read the directions for 34 to 36 and 49 to 51. And then on number 58, you're only going to do B and C.